In this video we are going to review subtracting fractions, which again should be reviewed from grade 7. Nice thing is it's very similar to adding, so we still need to find equivalent fractions with a common denominator, which is good. We're going to now, instead of adding the numerators, just subtract the numerators, okay? And so we need to make sure we do have the fractions in the correct order they are given to us. The denominator will also stay common, and as always, put into lowest terms and put any improper fractions back into mixed numbers. Okay, so if I was to look at something like this where I have 1/2 minus 1/3, so if I was to think of taking my circle and I have half of it colored in, and yes, we're going to pretend that that is perfectly half because Mr. T is doing the best that he can on his tablet. So here we go, I've got my half of my circle is colored in, but now I want to take away 1/3 of that. But it's kind of difficult to envision taking away 1/3 of what's going on in my circle, so I kind of have to think about splitting my circle again into thirds like this, and then I would be taking away this portion here in blue needs to get taken away. I need to take away something that is 1/3 of the whole circle. So that blue part I'm kind of taking away and now erasing. And so it's what are we left with, okay? And you can see that the piece is not as big as a third, it's not as big as a half, it's smaller than that. And if you watched the last video, you're probably going, well, yeah, that's because it is split into 6. Okay, and that's what we're going to get when we find that common denominator. So again, common denominator for 2 and 3 should be 6, right? If we count by 2s, we've got 2, 4, 6, 8, 10, 12, and we can keep going. If we count by 3s, we've got 3, 6, 9, 12, and we can keep going, but our common ones are at 6 and at 12. We want to pick our smallest common one. Now we're going to keep having common ones, but let's pick the smallest common multiple for both, and that smallest common multiple is 6. So I'm going to multiply my fraction on the left, top and bottom, by 3 to get 3/6, and I'm going to multiply the fraction on the right, top and bottom, by 2 to get 2/6. And so now my statement, instead of saying 1/2 minus 1/3, it says 3/6 minus 2/6. Now 3/6 is still the same thing as 1/2, so I still have the same fraction, just represented in a different manner. 2/6 is still the same thing as 1/3, just again represented differently. Okay, so now I'm going to write it as 3 minus 2 because the 1/2 came first, the 3/6 is first, so it does matter the order I do it in. So 3 minus 2/6, and that gives us 1/6 remaining. Okay, next one. Now if you want to see how I'm getting common denominators, go back and watch the adding video. I'm going to cheat because I've used the same numbers so that we can go a little bit faster through this video. I know you don't want to listen to me that much. So I've got 7/8 minus 1/4. 8 is already at its common denominator because I can change 4 into 8 by simply multiplying numerator and denominator by 2. So that gives me 2/8. And now we have 7/8 minus 2/8, so that's 7 minus 2/8, and that is 5/8. Okay, double check, 5, 8, no common factors, so that one is in lowest terms already. Then we've got 5/6 minus 3/8, 5/6 minus 3/8, and what we're going to do is change this so we have a common denominator of 24 is what I'm looking to do, and that's going to be multiplying 6 by 4 and the 5 by 4 to give me 20/24. And then to get my common denominator of 24 here, I have to multiply numerator and denominator by 3, and that gives me 9/24. And so now I have 20/24 minus 9/24. I'm going to subtract the 20 and the 9, leave the 24 as is. 20 minus 9 gives me 11/24. No common factors between 11 and 24. Now what do we do if there are mixed numbers, right? If we're subtracting mixed fractions, I'm going to do the same way that I did with adding. And in this case, actually changing mixed to improper is probably the better way to go, and I will show you just why in a second. So I want you to be changing mixed to improper. Then you still do the same thing, find your equivalent fractions with a common denominator, subtract your numerators, denominator stays common, and then as always put into lowest terms, and anything that's improper, put it back into mix. Now there is two ways to do it. I'm going to do the improper method first, and by improper I mean changing it into improper. So if I had 2 1/4, I'm going to rewrite that. I'm going to go 2 times 4 plus 1 over that denominator of 4. And then for the second one, I've got 1 times 5, because the denominator is a 5. 1 times 5 plus the 3, and the denominator is going to stay as a 5. So my new fractions are going to be 9 over 4 plus, and then we have our 8 over 5. And silly me, we're not adding, we're subtracting. All right, let's subtract instead, so that I didn't actually change the question on you. All right, so a common denominator for 5 and 4 is 20. So I need to multiply the fraction on the left, top and bottom, by 5, and that's going to give me 45 over 20. And then the fraction on the right, I need to multiply top and bottom by 4, and that's going to give me 32 over 20. Okay, and so I still have the same statement that I had before. I've just rewritten 9 over 4 to be 45 over 20. They are still the same fraction, they're equivalent, they just are written with different values. Okay, so I got 45 over 20 minus 32 over 20, 45 minus 32 all over 20, and that gives me 13 over 20. So that one's not so bad. Okay, now I like when you are subtracting to change your mixed into improper, so I would prefer you to do that with subtracting. There is another method, but I find it gets a little bit more confusing. So if I try to split them like I did with addition, I have to take away my whole numbers first, right? So my whole number is going to be 2 minus 1, so I'm going to look at that first, and then I need to add on. So this is why it's a little confusing. I need to add my fraction portion, and my fraction portion is 1/4 minus 3/5. Okay, so if I was to do this, 2 minus 1, that gives me 1. Great. Now if I'm looking at my fractions, again common denominator is 20, so I need to multiply here, numerator, denominator, by 5. So I've got 5 over 20, and then I'm going to subtract, there we go, and I'm going to have to multiply top and bottom here by 4, and I'm going to subtract 12 over 20. And as I write this out, this becomes a real problem, because 5 minus 12 does not work. I can't take 12 away from 5. So this doesn't work. This second fraction is bigger than my first fraction. So now what I need to do is I need to borrow from my whole number neighbor. And this is why I don't like subtracting this way, because I find that it's tough to borrow a whole number here, because I'm not working in a base 10 system. So here's what I mean by that. So I've got 1 plus 5 over 20, and then I'm subtracting 12 over 20. And what I need to do is, instead of thinking of this value as 1 whole, what would 1 whole look like if I split it into 20 pieces? Well, I would have 20 up top. That's the same thing as 1 whole. 2 minus 1 is 1, which is the same as 20 over 20. Well, now that I've done that, I can combine these guys first. And I can go 20 over 20 plus 5 over 20, and that's going to give me 25 over 20. And now I can subtract my 12 over 20 from that to give us 13 over 20. But it requires me to turn my whole number still into a fraction so that I can borrow and add together to this smaller fraction so that I can subtract from the other one. I think it's too confusing. I think it's way simpler to just change to improper first, and then I don't need to worry about any borrowing at all. Okay, so that's subtracting fractions. Hopefully, again, that comes as a review to you from grade 7.